Yeah, there's still. Hi, this is TSVWG. We are going to start the meeting in just a moment. See if I can press the buttons. No. Easy.
Now you need to hit the window. And
This?
full screen.
Try to do full screen.
Yes.
That?
Keyboard.
Is that this one?
Yes.
Whoa! Yeah, with supervision. Okay, I'm Gary Fairhurst. The man sitting here is David Black, who will be with us just in a moment. Wes Eddy is remote on Jabba. We're your TSVWG co-chairs. This is the IETF Notewell. The IETF Notewell is worth reading. It's not that exciting, but it's important to realise the IPR procedures for the documents that we bring to the working groups and the comments you bring at the mic. Please do this, especially with any technology of which you are aware, because it will be important as we go through the standards process, as you'll discover tomorrow. Please volunteer if you wish to be a note taker today. We have one. Notes will be taken in Etherpad by Teresa. We need a Java scribe for the session, and we have one. So the remote comments, remote questions will be relayed from Java. If you intend submitting a new draft, please consider inserting the TSVWG tag after your name in the draft name so that we see the draft and we know that it is relevant to this particular group. If you're planning to submit new work to the group, please be aware that this is quite a large meeting. We cover a large number of topics, so please submit drafts early. It's always possible to update a draft submission, but please bring drafts early to the working group, not the week before the IETF. All the documents that are in TSVWG that are mentioned today are welcome for review, either by submitting comments or by submitting a longer review as an email. Please do this, please contribute. This is the way we make progress. So now to what we've done recently. Well, it's always good to report that we've done real work. The LEPHB draft has now become RFC. It's RFC 8622. The new code point is defined in that and is now in the IANA registry. This is a nice result because this particular document is actually being talked about by other people. Other people are referring to it already. So that's good. We have 4 internet drafts in RFC Editor Q. 2 on the FEC subject, the FEC framework extension and the FEC sliding window RLC, which we've been through this working group for some time. Added a 3rd one, which talks about the pseudo-random number generator upon which they are based. So these 3 form a group together in the RFC Editor Q. a new contribution. The old contribution is the DiffServ and WebRTC QoS, which is still residing on a misref in cluster 238.
And we are now being promised or threatened that the cluster 238 floodgates will open next month, which should result in this draft finally being published as an RFC.
And that's going to be exciting. There's no IDs at the IESG, which means our area director has not got enough work, so we'll try and keep him busy during this IETF by sending things to him, if you wish. There's 2 IDs with working group chairs and authors after working group last call.
Okay, so it took 2 tries to get these drafts through working group last call. Mea culpa for not doing a good job in the first one. The drafts are now through working group last call. They're mostly revised except the second draft, which is the RFC 6040 update shim. There was some brand new text written on fragmentation after working group last call completed. That text needs review. There was just a comment this morning that the text may be problematic. I've sent out a comment suggesting that it is a concern. We need to figure out what to do about that text when its final form is. Once that's done, I can do the Shepherd write-up and gift Magnus with these 2 drafts.
Does anybody have any further comments or concerns regarding these 2 drafts on the working group last call?
Bob Briscoe, one of the authors. I just wanted to say that it was written after last call because of a comment in last call asking for it.
Oh, right. It's just that it was, it has an unusual amount of content to it for post-working group last call text, and therefore we need to take a little bit extra review time to try to get it right.
Marko Kojo. There actually is the same problem, the same conflict in both drafts. They have basically the same mechanism.
Okay. All right.
So please discuss on the list and we will see how to proceed from this. We have no IDs in working group last call apart from the discussion of those 2 that we just mentioned, but we have 2 IDs like to go to working group last call soon. Okay, the transport header confidentiality impacts draft will be presented at this meeting, and we mentioned previous meeting that this would be the time to working group last call it. So that will be discussed at the current meeting. The DPLP MTUD draft has been ongoing for some time. It is nearing working group last call. It is not ready yet, but it might be ready before the next meeting.
Okay. Okay. LFRS drafts. We're going to figure out what to do about those as the first order of business during the meeting tomorrow. So there's no comment here on process steps for them.
Okay.
Okay, we have, beyond that, 6 additional working group drafts we're going to talk about today. The SCTP BIS draft, there are the 3 LFRS drafts, UDP options, and tunnel congestion feedback. I think tunnel congestion feedback is not on the agenda this time, is not on the agenda for discussion this time around. The core mechanism in that draft is stable, and it will progress as other drafts that are taking advantage of it progress.
And the SCTP NUT is also on that list.
No, did I leave that off the list?
The 2 chairs didn't quite.
Okay, yeah, we somehow dropped SCTP NAT into a crack. It should have been on that slide. We'll fix that.
Okay, so there are a number of transport-related drafts, and I think it's very useful to call these out. Please bring up transport issues in other working groups, and please bring them back here if they need to be discussed. One of these is the PathMTU discovery hop-by-hop option, which was proposed as a working group item in 6-man this IETF. Obviously, this is a mechanism to work with PathMTU discovery, so it is relevant to transport. Discuss that in 6-man, please. There's an IPv6 reservation protocol. Do you want to say anything about this?
This was presented several IETFs ago. The authors are continuing to work on this. It will reappear at some point. It's not on this IETF's agenda. It's not ready for an update. Moving on to the next one, we have an L4S and DiffServ draft. This might be part of the discussion tomorrow morning, depending on which of 5 dozen directions that discussion actually goes in.
And there was a non-working group forming both on loops, which obviously has transport impacts as well as network internet probably implications there. So I'll look at the loops slides to see what happened in the loops path.
Okay, more transport-related drafts. ECN and NSH, this is a draft over in SFC that is going to make use of the tunnel congestion feedback draft. We have a couple of drafts on low latency DOCSIS. This is just FYI. Bob and Greg, I believe these are likely headed to the independent submission editor for publication roughly as is to describe what this running code actually does.
According to the chairs here and the ADs, yes, but we haven't spoken to the IC editor. That's in 20 minutes' time.
Okay, that's the intent.
These documents are presented to the IETF, so if you have comments or questions about them, please read them. If they go on the independent submission stream, they are not for change, but for clarification and understanding. Feedback would be very much appreciated.
Yeah, and just to clarify, they're documenting what's done in DOCSIS, so there's no need for the IETF or no ability for the IETF to change them.
Okay, there was previous work presented on LoLa, a number of IETFs, and this evolved. This work has been now made historic by a new internet draft, which is on NQB, which will be discussed. So that comes back as NQB. Interior documents, there's a tunnel MTU considerations document. MTUs are so important for tunnels, so please read and contribute to that. There's a fragmentation fragility document which is proceeded through Interior, explaining where fragmentation becomes fragile. And the SOX protocol version 6, which has been presented at many IETFs in the int area. And we're going to mention that again here because that could be something that has many transport aspects. So we'll talk about that later in the meeting.
Two SCTP drafts that are being worked on as individual submissions right now. One is a multipath draft, and the other is there's a draft on the retransmission. There's a draft on the retransmission timeout. If you're interested in SCTP, these are relevant drafts. Please take a look. Comments to the list. Okay, so now we get to the agenda. We're going to put the agenda up in a little bit to bash it. Document complication status, milestone reviews coming up next, and then a bunch of drafts. UDP options is expected to be one of the more interesting items on the agenda. Tomorrow is more drafts, including L4S and SCE. Okay, milestones review. Go through this very quickly. First two drafts we've just talked about. They're with the chairs after working group last call. We need to deal with the fragmentation text before they can be submitted to our AD and IESG for a publication request. Okay, next three drafts are the L4S drafts. No point in talking about milestones here until we have the what are we doing about them discussion tomorrow. Okay, we have three drafts that the intent is to try to get done between now and the Singapore IETF. The SCTP NAC is probably not going to make that July milestone. I think that one's not quite ready for working group last call. We'll have a discussion about that in a little bit. The other two drafts are believed to be close to ready for working group last call. While July, August, September dates may be aggressive, all three of those are likely to be working group last call before the next IETF meeting. And the remaining drafts, the SCTP BIS draft is currently guesstimated for end of this year. That may move out. And the other two dates, tunnel ingestion feedback and transfer options for UDP are reasonable guesses at this point. We'll figure out what reality looks like in Singapore. Okay, so here's the agenda to go bash it. We've mostly run through item 1 on document status charter and updates. There's a SOX update that'll be coming up right after this. Then we're going to do transport encryption drafts, both the transport header encryption impacts draft, which is one of the two that's closed for last call, and a new draft on lawsuiting for encrypted protocols. SCTP drafts, there's 3 of them there. 2 working group drafts, one is a new draft on retransmission. Datagram PMTU discovery, and then UDP options draft, where our hope on our goal in the UDP options draft is there's been a lot of discussion on the list. We're hoping to have a bit of design discussion here and see if we can chart the path forward on a number of the design issues that come up on the list in intertwined fashion. New work from the routing area working group on QoS management. There's a couple of drafts that we talked about briefly. QCI and DiffServ. We're actually probably not going to have a technical conversation in this draft because there's been some updates in 3GPP IETF leadership discussions. That is likely to be a very short status announcement about what the state of that draft is and what's going to happen with it. And then the non-queue building flows draft that I mentioned earlier. Friday. Oh, we have fun. This slide is going to be interesting. The L4S drafts, including are we ready to go to working group last call on them? What do we need to do? And there's going to be discussion around transports for L4S. Since L4S is supposed to enable different transport behavior, we need to discuss what is available way of transports to use L4S. Then we have some congestion experience. The 3 drafts listed there, discussion is going to focus on the first 2. The TCPM draft is here mostly for completeness, and that if SCE moves forward, they're going to need to do some TCP level signaling. That's a draft proposing how to do it.
And that draft will be discussed in TCPM today.
Mm-hmm. Okay. Rest of the agenda, DCCP, multipath, 3 drafts. Okay. Any other items? Anybody want to bash the agenda? Check that one off, it's been bashed. Okay.
Hey, do we get what to do with the computer?
Okay. We're done here?
Yeah.
Okay.
We do the socks.
Hang on, what, just.
We'll take socks next. So we'll take the socks option, socks V6 as the next item.
I need to get this thing.
Yeah, David will work out how to do this. Okay, I can give more history. This one's being presented as a heads up in this working group. It was presented in int area this time. And when I put the draft name up, we will ask, after a short review of what it is, whether anybody has read this document. The possibility could be that this item is more suited to transport area than to int area. So I will be looking for people to read this and comment on this within this group.
Right. Do I?
If you click on the link and then do back, it doesn't display properly.
Yeah, I'm not sure. Basically, Reload has fixed this in the past. It's not. So click where? So what do I need to do here?
scroll to the top of the page.
Over here. Yeah, it's very confusing. Let's just turn that on. See if that does it. It's filtering. It's done that. If you click on this, all right. There we go. Page's done that to me in the past. Firefox, I know the magic way out. Okay.
Okay, heads up. This is the draft we're talking about. It's a draft that was presented in Interia this meeting. It's been presented previously in Interia. There's a one-page summary here, which describes how the SOX protocol provides a update to the way SOX is handled. It talks about DTLS support, extensions via option, how the TLS handshake's handled, and basically talks about transport issues relating to building a SOX proxy. Could I ask if anybody has read this document in this working group? Could you please indicate if you've read it? Read the previous version, thank you.
One person.
That's pretty good. Okay, but you get the hint. We would be interested in receiving feedback on this draft in this working group. Please read, please comment on the list. Please consider this as a potential TSVWG work item, and please provide feedback. Does anybody have comments on whether this is a suitable item for work within this working group? Okay, I see no adverse comments, so please review. Would anyone like to volunteer to read this? It's not that hard. Well, we will try and put pressure on. We've got another working group meeting to call that one. Fine. So the next item is transport encryption, Colin.
At least we know what the solution is.
Yeah. Between the two of us and the whole working group, we can work. Right. So,
has to
Colin,
be said
introduce
that-
yourself.
Hi, I'm Colin Perkins. As I was just saying to the chairs, I'm pleased I'm not the only one who can't work with Chromebook. It seems to be that the hardest part of being a working group chair is finding the slides.
Slides in a minute. All right.
Next one, that one, yes. All right, good. Hi, I'm Colin Perkins. This is a draft that Gary and I have been running for a while on the subject of the impact of transport header confidentiality on network operation and evolution of the internet. So this is the -07 version. There was an individual version which got up to about -10 before, I think. So this has been discussed a bunch of times here and also in some of the operations groups. So we think this is pretty close to done. The changes since the last time are fairly small. We got a bunch of feedback on the mailing list. Thomas Fossati gave us a bunch of suggestions on how to clarify the text, primarily talking about improving the various introductory sections, and also gave some suggestions for how to address the issues which we raise in the draft. In particular, he had a bunch of, I think, really good ideas about potentially using machine learning to solve some of the problems and be able to identify the traffic. We tend to think that while this is potentially a good idea, it would be expanding the draft too much to add that sort of material to it. So what we think is the right thing to do here is to keep this draft focused on identifying the problem, and leave other drafts to recommend solutions for the problem. So we just keep this focused on this is what the concern is. We also got some comments from Rutger, and I'm sure I pronounced that wrong, Rutger Gieb, suggesting a bunch of additional references on how operators use the information, use passively collected transport information to help manage their networks. We also got a bunch of feedback from Tom Herbert. Couple of issues here. One was on the utility of adding extension headers such as connex headers to carry measurement information. And his feedback was that he believes that the draft underestimates their value and overstates their disadvantages. I mean, yeah, we certainly agree with him that these types of mechanisms can be used to carry these sort of measurement information. I don't think we've seen so much deployment, so it's hard to evaluate that. But in the end, it's a judgment call, and yeah, we should if the text isn't if the text is too far in one direction or the other, we should try and align things. But hopefully, we've addressed that. Maybe not.
Tom Herbert. So on point 1, so a later version of the draft update the text to be a little more positive towards extension headers?
I think we did. Maybe we didn't. I thought we'd done that already. But if we haven't and it's still not positive enough,
I just looked. It still looked a little negative. Also, the statement that something like current data suggests that extension headers don't pass through the internet. Presumably, that's referencing the RFC that was done, I think, in 2016, about a little not fresh data. So I know we need to get better data. So
please read the latest version and check whether we fixed it, because I would be quite happy to change that sentence to a survey in 2016 then found this and note its history rather than its current relevance.
It's fine either way. It's good to reference it. I mean, it is a known issue. On the other hand, it's a known issue that we're trying to resolve. There are a lot of efforts to get extension headers going in IETF, and it would be good to at least suggest that they could be used. For point 2, the wording for this will be interesting. I'm not sure I've ever heard of the term intentional ossification. Could be interesting. I don't know what to think of that.
I mean, the idea here is that a working group or whoever it is designing a protocol may make an explicit statement that we are going to declare these features of the protocol stable for all time. And if you're building devices which look at the protocol, you can assume that these things will not change, and we reserve the rest of it to change. And I guess the quick invariance would be the topical example of that.
Joel Yegley, ultimately, when we bake something into an RFC and then move it from proposed standard to standard, like we're kind of doing that. I mean, that is literally what we're aiming for, is for things to not change too much. I mean,
yeah, but I think there's a difference between that and saying the working group has made an explicit commitment that we are never going to change the meaning of these bits.
Well, I mean,
rather than saying this is what it currently is, and we,
if you want to change the three-way handshake in TCP at this point, I mean, good luck. But I mean, it's not just a product of it's being standardized that means it's not going to change. It's actually the fact that we've been using it for 35 years.
Yes. I think the word ossification might be causing the confusion here. Further down in the bullets, the word stability is used, and I think that's the point being made here.
Yes. Yes. I think that the main point is that the harm here comes from devices on the path evolving in a way that prohibits us from changing the specifications in a way we want to change. And if everyone is happy that these bits are never going to change, then it doesn't matter if devices, if people build middle boxes that use those bits and don't let us change them. It's when we believe that we should be able to change the meaning of those bits and we can't, that there is a problem.
Tom Herbert. So I think one interesting aspect of this that we want to stress is we now have 2 major transport protocols to evaluate, and Quick has done things differently. I believe that
we have more than that,
one of the bits
yes.
in the Quick header is public. Some firewall vendor decided that this bit's set to 1 all the time, so I'll put in my firewall that it's set to 1 all the time.
Sure.
Classical ossification
Sure,
that we want to
sure.
avoid, right?
Yes, yes.
So looking at Quick and TCP, I think they need equal consideration now because they are different. So
yes.
Quick does not
we have much more than just the 2 of them because RTP is very widely deployed, for example.
Yeah, sure.
And is running into these ossification issues.
Matt Mathis, there was a time when there were some people in a misguided effort to prevent steganography in our protocols, wrote a lot of code, a lot of documents that said things like you have to enforce must be 0 in your middle boxes.
Sure.
This was ugly as far as I'm concerned. It's deliberate ossification. I think that tone has been reduced, but there's always the opportunity for somebody to say, it's always a 1 or it's always a 0. And if it's something different, it's something suspicious.
Yes.
And what has made it worse is there's occasionally been attack vectors where those were the signatures.
Yes.
So was that a comment on the draft or the presentation?
On the presentation.
Yeah, sure.
Sure. We're getting a little off topic, but the greasing stuff is also something that hits into this space. Yeah. All right. So in terms of the draft, we've done 2 revisions since the Prague meeting. 06 revised the introductory remarks, added some discussion of the OEM-related metadata in section 6, and updated the conclusions, made them a little more focused. The -07 again revised the introductory remarks, removed a bunch of duplication, put some of that text into the conclusions, and actually made the conclusions, I think, read a lot better and actually conclude something now, something that improved it, and that there are a bunch of other details around the rest of the draft. So hopefully we've now addressed all the comments. I believe there are a couple of minor editorial nits we have outstanding, which we will get to in pretty short order. Other than that, we think the draft is essentially ready for working group last call. So our plan was to do a revision shortly after the meeting to address the details, and then we believe this should be last called.
Mike?
Alyssa Cooper. Thanks, Colin. I was wondering if you could talk about the review that this draft has gotten from the security area or security area people.
Yes.
Okay, so we discussed that last meeting because it was before the last IETF. We got a security review. We worked through it was quite a long one, which was really good. We worked through the comments and responded to each of them in turn, and then we updated the document. We put in text to address nearly all the comments, but there were a couple of comments where we wrote the response on the mailing list about why we didn't think the extra text was going to be helpful in the document. So that's the current state with that review. The reviewer has got back a couple of times to say that he's read our comments and he's talked to him, but I don't know whether he's posted an update on whether he thinks the comments were fully addressed on the mailing list.
We also had a very long discussion. So I think that was Chris Wood, I think, this time. And we also had a very long discussion with Stephen Farrell on an earlier version a few months back.
Okay, that's very good to know. Thank you. So this document is not entirely unrelated to a prior document that was published, the draft MMWG encrypt. And I think there's like a chance that some of the language in this document hits the ears of people from security and applications areas a little bit differently than maybe the people in this room or people who work in operations. And I guess
we have presented it in the ops area, OPSEC, I think, a couple of times. Yeah.
Okay. To the extent that some of the same concerns could be dealt with while the document is still in the working group, I think that would perhaps make for a smoother process than what we went through with the other document. So that might just mean, advertising widely when you're doing working group last call, or we can certainly socialize this in the IESG if that would help. But I think it would be, good to get the feedback earlier if there's going to be feedback of similar nature.
Sure.
At the very least, the working group last call will be cross-announced to SAG in the security area.
Okay, that's perfect. Thank you.
And we welcome feedback. The idea is to build consensus on what we have previously been using these fields for and what the implications, without going through solutions.
Yeah, sounds good.
I'm going to stay here.
Okay, thank you.
Do you want to call out what the procedure is then, David?
Getting there. I think it's behaving itself now. The trick of telling you you only want to do the trick of telling you only want to do transport seems to have focused its attention.
So do we want to go for working group last call for this?
Yeah. I think the plan here is that there'll be revision in the near future, and that revision will go to working group last call. Since we're talking about August, it's probably going to be longer than the usual 2 weeks, and it will, at the very least, be cross-announced to SAG. Sounds like we probably also ought to cross-announce to some list in the ops area.
So that will be good. We'll take advice. Maybe ask the OPSEC people where to post.
I'm Igor Lubashev, and I would like to talk to you today about packet loss signaling in encrypted protocols. So that's one of the issues that the previous draft have identified, and so my job is to tell you more about the problem, just to show that there is a problem and propose a solution. So I'm a transport guy. I like to think of my networks as a collection of very dumb pipes and then stop thinking about my network. But for that to really work, there should really be a plumber somewhere who is trying to find the leaks and patch them. And if you're such a plumber, if you operate a network and somebody calls you and says, I'm experiencing packet loss, what is the first thing you want to do? You want to see if you could observe the problem. And then you want to figure out, is it loss in my network or is it any of my peers? Whom do I call? So what do I do? If I'm looking at a TCP flow, life is not that bad. There is a number of tools that can observe sequence numbers, ACK numbers, can figure out where there is loss, is it upstream, downstream. But if I happen to be looking at quick flow, I'm in for a very long night, because by design, quick doesn't give you any information about not only where the loss is, but whether there is any loss at all. So what do I do? One alternative is just look at TCP flows between similar endpoints. Use that. But if that doesn't work, what's next? You could think of nuclear option, which is basically, let me just block quick entirely, temporarily on that link, and force TCP failover and troubleshoot then. Well, as crazy as it sounds, it might not actually work either, because network may treat TCP and UDP quick flows very differently. So what's next? Now, before I'm going to go further, there is one question that I'm asked often. So I'm from Akamai, and people ask, you're not a typical network operator. Why do you care? I mean, it's somebody else's problem. So the way I look at it is that if you have content on the internet, if you have a service, you probably derive benefit and value from it actually being available and performant. And if you're CDN, that's what you're paid for, to solve all those network problems. And as an Amazon customer, if my package doesn't arrive at my desk, at my doorstep, and I get some excuse that, well, that's because some trucking company truck ran out of gas, I'm not going to be super convinced with that. I mean, my business relationship is with Amazon. I expect them to deliver the package. So if that was convincing, we have a proposal. It's basically using 2 bits. I'm not going to go into detail, read the draft, but there is a Q bit, which stands for square signal, and it's it's a mark that's alternating every n packets, zeros and ones. And there is an L bit, which is a lost signal. That's counting the number of packets lost as determined by the transport protocol, such as QUIC. So, for example, in this picture, we have a number of packets from sender to receiver. The red ones are lost. So one RTT to one RTO later, the protocol QUIC figures out they're lost, and two future packets are sent with L1. How can you use the signal? Well, end-to-end loss is just a fraction of packets you observe with L equals 1. Upstream loss is a fraction of the packets in each Q block that are missing packets. Downstream loss you can figure out from the other two. So you can notice that we don't specifically talk about where to put those 2 bits. It's been proposed everything from IP header to QUIC header and really anything in between. The purpose of this draft is to point out the problem, propose a solution framework using the 2 bits. And once we have consensus on that, I'm sure we can work on a draft in the appropriate group that will find the home for the bits. So this is not a purely theoretical work. Akamai has actually implemented this scheme in our production servers, and we've been serving traffic like that, QUIC traffic, for a while to a number of Orange customers in different countries. We have data for this, and tomorrow at MapRG we'll be talking a lot more about data from different countries, what the data means. For those who are curious, we used the 2 most significant bits of APTTL to carry those bits. It works. Now, the encrypted protocols do what they do for a reason. So one of the important reasons is end-user privacy. And the proposal we have is trying very hard to make sure that nothing more is disclosed to the network than what QUIC already discloses. So separate counters for each flow, subflow, separate counters for each 4 tuple, separate counter for each connection ID. The other important thing that encrypted protocols like QUIC worry about is protocol ossification resistance. And because loss signaling is not an integral part of the protocol, it's very convenient to basically do what QUIC does already with a spin bit, with a latency spin bit, which is say that 20% of connections must use pseudo-random, basically random looking garbage in those bits. It's very easy for observer to tell a real signal from no signal. And for middle boxes, that's an incentive to not ossify on that. So that's all I have for today. Please get in touch with us. My goal for the future is to make sure we have a robust discussion about it on the mailing list, which already started. And later on, we'll see if we can get consensus and get it adopted, and then work on the actual draft that will find the home for those bits. Thank you.
Let's take quick questions on the presentation. We're short of time, so please be quick.
Extremely quick.
Yeah,
so I just wanted to point out to Colin, if he's here, that I think it'll be of great interest to the Quantum Internet Research Group to see qubits in use in transport protocols.
Okay.
Thank you, Aaron.
Tom Herbert, 2 quick points. One is, I think this is great, but I wonder what else there is, like what other information people are going to want. Like what if I want a spike in latency? So I'm worried if you get a mouse, a piece of cheese, they're going to glass of milk and all that. So I could see this becoming the avalanche. Part 2 of that is protocol agnostic mechanisms, much better than protocol specific. So it, Quick has a few bits, but what about the next protocol and the next one after that, and how do we get the unified mechanism?
Thank you. I also note that this is one presentation in a space. There are other people who could have presented this IETF on topics that are extremely related. So, thank you for the general comment. That's good.
Martin Duke. I actually want to make the opposite point. If it actually is in the quick header, then of course it's authenticated. I'm wondering if you've thought through the threat models if we put it in the IP header where anyone can mess with those bits.
Well, yes, I actually did think about it. And well, as you see in our current thing, we do mess with IP header bits. It's not going to be any different from what people can do right now. So, but if it goes into a quick header, it will be authenticated and it will not be subject to manipulation by the path. So there are advantages and disadvantages to any of the proposals. So that's why we don't directly dive into pick the header right now. I want to make sure that people agree that there is a problem and that we need to solve it, and this is a method to solve it. And we can have a discussion about trade-offs between different headers. That's a good discussion. I would love to have it separately.
So I'm sorry, just to, maybe I missed it in your response, but having thought about the threat model, do you see any serious problems with putting it in an unauthenticated part of the header?
If the sender is playing fair and keeping separate counters for each subflow, each quick connection ID, if it's quick, I don't think there is a threat model in that sense. That's my thing. That's my understanding.
Thank you.
Only a short consideration. Mauro Cocilio from Telecom Italia. I suggest to add a reference to RFC 8321 in your draft. That is the RFC that defines a square wave to measure packet loss. And the user case that you put 2 different points. Okay, yes, okay. 2 different use case that you use 2 different measurement points to understand the packet loss inside a network.
So you can definitely do more. And so this is using just one probe, just kept looking at one direction of traffic.
Yes, yes.
Once you do that and you identify which direction the loss is, you could move the probe or have another one already available. That's just another way to use the technique.
Okay. Yeah. We need to call an end to this. We're nearly 20 minutes behind schedule.
Okay.
So I'm going to close. We're going to close. It needs. All right.
Philip Hurdley, just have you looked at the congestion exposure work, the Connex work? It seems to be quite a lot of similarity with the ideas going on there.
All right.
Yep. Thank you.
Okay. Thanks.
Mm-hmm. So that's a classic example of bringing a topic up that should be continued on the list. Please think about implications. Please think about which header bits could appear in. Please think about requirements. Please talk to the authors. Please discuss. Next slide. Michael. Thank you.
Hello, my name is Michael Tüxen. I'm talking a bit about RFC 4960 BIS. That's the base spec for SCTP. We have an RFC describing a large set of erratas. And how do I switch to the next?
You talk.
Okay, just next slide. That's the status. So the first revision 00 of the draft was just to move from the end of tool chain, which was used in when producing RFC 4960 to the XML stuff, done in a way that the text version looks as similar as possible. No, the first version was the identical version. The 01 version was switching to XML with minor differences. The version 02 integrates all the erratas from the errata document. So that's all the changes we sort of agreed on in RFC 8540. There's some stuff which needed changes, like updating references to RFCs which have been updated, and some editorial stuff which is in the 03 version. What is in progress is the 4th version, and this comes back to a comment from Gori. We used in 4960 a lot of may, must, should, not in capital letter. And the request was to remove this stuff to either capital letter, must, or a different wording, so that when you read the text, you are not arguing whether this must is meant as a mandatory language or not. This is right now in the GitHub repo. We need to go once again to the changes to make sure everything's fine, and then it will be submitted. What's left is one issue brought up on the GitHub tracker, which is related to setting up SCTP associations. So if an endpoint knows multiple IP addresses of the peer, the current API in 4960 only allows you to provide one of these addresses to the associate primitive and then set up the association. The socket API allows you to provide this list of addresses to the endpoint, and then it already uses multiple addresses during the association setup. And this is a feature which is requested by operators. And when they try to talk to vendors, then vendors come up and say, well, this is not specified there, so we don't have to do it. And so we will update the text in the API section, replacing the single IP address we are providing by a list of IP address we are providing, making clear that it is informational only, adding a link to the socket API stuff, and add some text to the document saying, if you know you set up a list of IP addresses, make use of them. And the last thing is sort of layout improvements. The XML code reads ugly. Just that the text version looks like 4960, and that will be cleared up at the last step to look okay in HTML and text, but not identical to 4960. So the idea is that you can go through the data tracker, compare the revisions, and can double check what has changed, and you know exactly from the versions whether it's only editorial or is content changing.
So, a couple of questions. First question is, there was another draft uploaded that talked about next generation SCTP.
Yep.
This was an individual draft. It's been around for a while. Is there anything in there which needs to be put into this document? Have you looked at it?
So that document lists a couple of issues. A couple of points. One point is to integrate almost all extensions we have right now in the base spec. I don't think that's a good idea, except for one document, the IBIT, which was integrated in this. The other stuff listed there is either additional work or changing concepts.
You've read it?
I've read it, and I don't think anything applies here except the IBIT, which is done.
That's fine. If the working group thinks that there are additions to this document, please either come to the mic or let us know on the mailing list, because this document is meant to be a stable document that reflects implementations and our best understanding of this standard. So please speak up at this stage if you think there's anything extra needs to be added to it. Does anybody wish to comment in the room about something that they think should be added into this revision of the spec? Then when will you be ready to continue to publish the next revision, which should be one that is clean by your...
The next version will include the musts and shoulds, so it will have the text set up. I think I will talk to Maxim tomorrow, and then we can submit it.
Okay, shortly.
Making clear that we will read it to catch things, but we can fix that later.
Okay, heads up then. Speak quickly if you think there's new additions needed. Be ready to review this, please, if you're interested in SCTP. Next slides, please. So learning algorithm.
Should be the net document. Yep. You can go to the next slide. Yeah, so this document was sort of considered ready for working group last call by the authors. Then two people read it, pretty detailed. Gori was one of them, and he made a number of editorial and clarification things, and one remark in particular, basically making it clear for an endpoint developer or a middle box developer which sections apply to that role. So we have common text explaining these things, we have common text giving examples, but where we describe what needs to be implemented, it's made clear in the headers of the section or subsection whether this is a consideration for endpoint implementers or middle box implementers. That's integrated. So I think I addressed everything Gori reported.
Thank you for doing that. I've read it. It appears to do what you're saying.
Okay. And Maxim also provided a detailed review. He has 63 comments. So I talked to him in person, and the comments with most impact we discussed and came to the conclusion that they will not be integrated. Some of them was like ideas doing the stuff in a different way, and we discussed why we're doing it in that way. The other comments, at least as indicated by Maxim, are some clarifications, editorial stuff, maybe missing a reference, missing some wording. That will be addressed in the next draft.
Any questions? Please complete this long-going piece of work so we can publish it.
Okay.
Next up, Maxim.
Okay, hello. I'm Maxim Proshin, and this is a status update on another CTP work that I've presented firstly in the previous IETF. So I will quickly go through motivation and proposal and mainly focus on updates and improvements. So the problem that we try to solve is well known, is that if you retransmit data chunk and you get acknowledgement back, you cannot distinguish if it acknowledges the originally sent data or retransmitted to one. And there are basically two use cases: when you have real loss or when you have spurious retransmission. Next slide. So the idea is quite straightforward. We want to use one bit in data or iData to indicate that this is retransmission, and the acknowledgement on retransmission should also include that bit. And we thought about different ideas, more bits, maybe new SAC that will be more complicated, but we came to conclusion that this is the simplest approach that addresses all our use cases and needs. So this usage of this bit requires negotiation, and basically there are two main rules. The first rule for the sender, that it should set the R bit every time it retransmits data or write data, and the sender must immediately respond by SAC with R bit when it receives data or write data with that bit set. Next slide. So since last IETF, I've submitted a new draft version where I added the description of SCTP improvements from this mechanism. This was main feedback that I received there, and I will describe it in the next slide. I also added some clarifications about the issue with multiple retransmissions, which is one of the challenges for this mechanism, because when you have multiple retransmissions and you get acknowledgements back, you cannot distinguish them. But still it brings improvement, because you can distinguish original transmission and you can still detect spurious retransmissions. So this still, have some improvement. And I also made some editorial updates. We also implemented the negotiation mechanism in our implementation. Previously it was some proprietary mechanism, but it's not yet in the live network. I think it will be there till end of this year. We started collection of data. It was requested last time, I think. We focused on signal traffic profiles to show the improvement. So I hope we will present it next time. And yeah, we continue interoperability with Linux STP. So this is what can be improved if we use this retransmit bit. So there are some mechanisms already in SCTP that will be improved: RTO calculation, path fail detection, quick failover, where you have issue with this ambiguous acknowledgement. The other big area that can be improved is detection of spurious retransmissions, because when you have spurious retransmission and you get sucked back without R bit, you can already at that time understand that there was a spurious retransmission and you can react accordingly. You can at least notify your application about that, or you can adjust your RTO settings, because one of the common issue is some kind of misconfiguration of minimum RTO and SAC delay parameters that leads to spurious retransmissions in the network. Or you can even recover your congestion state, because when you do spurious retransmission, you basically reduce congestion variables, and when you detect that there was a spurious retransmission, you can recover it. The other big area where we use this mechanism is so-called calculation of maximum MAC delay. It's also to prevent spurious retransmissions. It's similar to how it's done in Quick. But I mean, the idea is that you dynamically calculate maximum MAC delay, but if you have retransmissions in the existing mechanism, it brings some problems. You should always be able to distinguish between what SAC actually acknowledges. Next slide. So implementation status is almost the same as it was before. So we have it in Ericsson SCTP enabled between Ericsson SCTP endpoints. We have also local patch for Linux SCTP. It's without negotiation, mainly used for interoperability tests. So improvements are implemented in our SCTP, not in that patch. Next slide. My plan is to close all TBDs in the next version. I think it's 2 or 3 of them. As I already mentioned, we plan to share some data of these improvements. There are different use cases, not only with spurious retransmissions, but also some other use cases. And we continue interoperability with Linux SCTP. And if, there is interest in this work, we want to adopt it in the work group.
Okay, so what's your intention for this draft working group? Work through these plans and then ask for working group adoption of the next revision?
Yes.
Okay, we'll make a note of that, and we'll probably see this back on the agenda in Singapore, right?
Yeah.
Sounds good.
Anybody have any questions? Please read the draft. We expect it to be on the agenda in Singapore, so if you're interested in SCTP, please ask questions, and this body's obviously interested in SCTP.
Michael Turkson, one question. Do you need a negotiation, or can you just, you can set the orbit, it's ignored by the receiver if he doesn't understand it, so is the negotiation required?
Yeah. I mean, if you set orbit in your sender side, you still want to know that the other side will send you SAC with orbit. Because otherwise, if you get SAC without orbit, you can mistakenly think that your first original send was
so
acknowledged.
You need the negotiation.
Yeah. Okay. Or, I mean, in our current implementation, we just use the second bit to negotiate, so to say. I mean, the receiver always sets that bit to show that I support this.
Okay.
But we don't want to use the second bit just, to not waste bits.
As David said, it looks like a good plan. It looks like there might be benefit, but the question is it worth the complexity? So please come and tell us. Next IETF.
Okay, thank you.
Hi, Gori First. As an individual talking about DPLP MTUD, I wasn't sure whether you could have coloured slides or not, so this IETF have gone colourful. DPLP MTUD has changed significantly in that it's used the new markup language for RFC XML, and therefore we have some SVG diagrams in. Thanks, Magnus, for inviting us to join this experiment. All the diagrams that have been rendered to SVG, go look at the HTML version and you'll see the effect of using the new format. We removed Appendix A because Appendix A had been introduced and was useful to us going through, but really was a duplication that became less and less easy to justify because it was just a representation of the same thing. It's gone, it's no longer there. Removed a section on DPLP MTUD with UDP options, and we put it in a separate draft. We have now talked to our AD, and we probably will refresh this draft and keep this active so that we can capture what happens when you use UDP options with this. We don't intend to put that back into this particular document. We'll keep it as a separate item. And we shortened the description of phases. We introduced the idea of phase to help people understand an overview of how the algorithm worked. We really want that to be a discussion of issues concerning the whole way in which this works and not going into the details of the state machine. So we will probably shorten this yet further. I'm not aware of... Oh, I wanted to draw a picture though. This is what it looked like before. And this is what it looks like now. See if you think that looks better. Before? After? Okay, whatever. Before was better. Yeah, you can get the text version.
Are you planning to be a poster child for SVG in the new RFC format?
Yeah, right. You could talk about the implications of that. Okay, so no, seriously, I want to keep this short. We think the state machine is stable and usable. We presented that last IETF. We haven't discovered anything to change our mind. We are still gathering experience with paths and methods. There will be research issues come out of this because we don't quite know how the internet works. But we believe the method that's proposed here is finished. As a framework, we believe it is finished. As a set of states, we believe it's finished. We will be updating the draft, so we're not asking for working group last call next. This IETF, we will be asking it before the next one as we finish the document. We have some author comments to still resolve. We're still willing to take feedback. So if you have any questions or feedback, please tell us. If you have a new implementation, please tell us. We know 4 different implementations in different ways of this. If you've got an idea of implementing it, please talk to us, please tell us.
Okay. A couple of process notes. As Gori said, expect this to be last call, working group last call before the next IETF. And on the first slide, the removal of the UDP options material to a separate draft was an executive decision by your working group chairs to move this draft along and hopefully get it published and stable without waiting for UDP options, which, as you're about to see, is going to need some work and may take a while.
Okay. Any other questions? Has anybody read a recent version of this? Please read it for the next IETF where we're about to finish this.
Tom Herbert. So I can't say I read it, but I did have one question. Is there an implementation of this?
Yeah, there's four. There's four attempts. There's a FreeBSD work, which is on the Git. It's not being upstreamed because it won't be until the spec's finished. There is UDP options, which is our test implementation, which we're keeping up to date, which is again on Git. There's been another implementation. Do you want to talk about yours? And we did one in Mosquick at the hackathon just to prove it could be done in Mosquick.
Okay. I think it's helpful to put implementation information in the draft if you haven't already, because good to have a reference to it.
I don't know what we'll do, but we're definitely going to Shepherd write-up because we'll have to send that as the working group progresses it. I'm not sure we'll put it in the draft.
Michael Jackson, regarding the implementations, we have one demo application thing which runs over UDP, where we do the message flows, and the other one is we have sort of code for SCTP. For a bit of an older version, doing this in SCTP.
SCTP has been doing something like this for quite a while, which is why we've been basing this on fact rather than just fiction.
Yes, and it's the only thing you can do when you use it in our WebRTC.
Thank you. Time to become Joe Touch, I guess. Is that right?
Hang on. That was weird. It all set up and decide to do something.
So Joe's not able to make this particular meeting. Joe's in LA. I believe it's sunnier and warmer. But I'm going to try and summarize Joe's slides. Joe's seen rather a lot of comments on the list in the last period, particularly just prior to the IETF, and he has a number of pending updates. There's a lot of wordsmithing and various things to be done. Right, there's updates particularly on the use of the OCS, which is this checksum over the options area. It appears to be a nice thing to be able to check the validity of the options, but as we discussed in previous TSV meetings, this is important for traversing middle boxes that do strange things with checksums. If you don't do this, then you don't get through the middle box. And even more frightening, if you don't do this, you don't get through some of the host adapters, which offload and then check in two incompatible ways. So please add the OCS was a request made to Joe, and Joe has now made it mandatory.
On OCS, I think the primary issue is worked. I mean, the crucial text here that everybody's sort of in final agreement on is if the UDP checksum is non-zero, then you have to use OCS. We have some corner cases in the tunnels area where if the UDP checksum is zeroed, now what? Which will work. Will work out in the list.
Okay. So I think this reflects discussion on the list. If you disagree with what's written in the slide deck, then please bring it up again on the list, and Joe will produce a new revision for the OCS work. There was a request on the list that length of options should be increased so that you can declare options that are longer than 254 bytes. This seems like an odd thing to want to do, but one of the uses of UDP options is to send fragments and possibly other data in the options space. So this limit becomes a silly limit when you're using this for fragmentation. For those of you who don't recollect the story, we put the fragments into the options space because we don't want them to be inadvertently delivered by a UDP receiver that doesn't know how options work. So this protects them from being delivered by accident, and it requires a longer option. Joe recently announced that the length field of 255 would indicate that the length is followed by a 2-byte length field, which gives us up to 64 kilobytes of options. Please don't use that much. I'm pretty sure that won't work. But it's big enough. And we don't support jumbograms, but that's another story. I can't move.
Does it work?
No, you move.
There we go.
Okay, so there's been a lot of looking at this draft and how it works, and there was talk about the structure of the options field. The options field is a kind of value, as in TCP options kind, and
all these topics come from previous slides. This is an outline of what's coming. So
okay, shall I just go forward?
Let's go forward and start trying to deal with these.
Yeah, I'll try to. Yeah, good.
Hang on. Okay, this is note mostly from Joe of stuff we'll need to get back to, which is that with some of the stuff we're mucking with, we're going to have some impacts on options and option processing. In particular, one of the things you're going to hear on use of kind is going to impact processing. Just a heads up that we're going to have to go look carefully at this processing text. Okay. So
this is Joel's position.
Yeah. All right. You want me to go try drive the first one since this on the
okay.
on.
Wait a second. I'll first start. The original options field mimic TCP options rather than IPv6 options. So all options were just options. In IPv6, the indicator allows you to have a flag which indicates that the option is critical, and that impacts the processing of options. And the question was, can we have something a little bit similar to this? Tom was a part of this discussion, other people also. And Joe's response is this. David, your cue.
Okay, so this is about now where it says must support flag. So there's two things going on there that we need that we're going to need to try to get some direction. The first one is Joe's been quite adamant that you can't have, so the crucial thing here is you get a critical option. It's marked as must be understood, and you don't understand it. The first bullet says that not understanding an option can't result in packet drop because a legacy receiver won't even know to look for the option, isn't going to drop the packet. Any objection to that view in the room? Seeing no objection.
I think Tom Herbert should have a quick comment on this because it was his point that started this discussion.
One clarification: what is the expected discussion here? So we're trying to resolve the issues here, or is this something
everything we do here will go to the list. I'm looking for a sense of the room here so that we have some idea of where we're going from here.
Joe's summary slides are presented.
Okay, let me defer for a minute and hear what others have to say.
Yeah, sure, that's fine.
Okay. Matt.
I'm worried because I haven't read enough of this stuff, but it seems that this prescription requires rewriting packets in places where you might not want to do that. Is that true? To drop the headers without dropping the
No. This is receiver behaviors. The receiver has received a valid UDP packet. The payload's fine. Receiver starts going to the options area and says, I understand this one, I understand this one. What on earth is this? Oops, it's got a critical indication and I don't understand it. The first thing we just went through was that if this happens, the most you can do is toss all the options area on the floor. You can't drop a packet because you didn't understand something in the options area.
From
It's
Jabber.
receiver only.
Mike Hurd, yes.
Thank you.
Cool, thank you. Yes, I figured, I knew that was Mike's position.
Magnus Westlund as individual. I'm also fine with, I think that's the right case to just drop the options.
All right. Okay, so that was part one. Part two is I've already given the game away. We've had some discussion on the list about whether to put in a critical indication of some sort. It's been talked about as a critical flag, though I think the proposal on the table is to take the range of possible option kinds and mark some range as critical and the rest of the range is critical. It might be half and half, might be quarter and three quarters. We can figure that out on the list, where the semantics of an not understood critical option are at least to drop to cease option processing at that point.
Tom Herbert. So I think it's more than that. This bid is based on what IPv6 did for hop-by-hop options and destination options. And so the two higher order bits in an IPv6 option type indicate the disposition of an option that is option type that's unrecognized by the receiver. There's two bits because there's also an ICMP disposition, but we don't need that here. So fundamentally, IPv6 says you do one of two things. If you see an option you don't recognize, you either skip it and continue processing options, or you drop the packet. And the reason you drop the packet is because if you don't recognize that option and don't process it, the processing of the rest of the packet may be fundamentally incorrect.
Okay.
And that last part is significant, because if you don't have this bit and you can ignore any option, that means you can never have options that are interesting, that like modify the data.
You can't modify the UDP payload area, as in the normal UDP data,
Yes.
according to the spec.
Yes. Part two of this.
Yes.
There's part two of this though. There are two use cases here for UDP options.
Mhm.
So one is where you have a trailer, in which case you have an actual UDP payload. In that case, I completely agree. However, the rule is simple. If you're in that mode, you can't send any of these sort of options. So if we use this bit approach, you should never see that bit set in any of these trailer options, because it's invalid, because those options can always be ignored. But in mode 2, where the UDP length is 8, there's no such thing as a legacy receiver. Legacy receivers don't see any payload or anything.
Yes.
They essentially drop the packet.
Sure.
with a caveat. But if it's a receiver that processes options, then it can follow the rules, process the option list. If I see an option I don't understand and it's important, drop it. And don't forget, in that case, there is no technical UDP payload. There is payload that's in the surplus space. We can do whatever we want with that, because that's not UDP payload, so we can change it and encrypt it or whatever.
Are you advocating that if there is ever one of these options set that says it's critical anywhere in the list, then you should drop all the option processing?
You should drop the packet.
So we should do a 2-pass through the option space?
That's the IPv6 way.
Well,
yeah, and
what's different here is that IPv6 defined that option behavior as part of defining IPv6. We're retrofitting here and not disturbing the behavior of existing UDP payload when the payload is present is definitely important. I'm not sure about the zero length conventional UDP payload case, but I am certainly dropping the packet when there's real UDP payload there, because you got a bad option is a problem.
So we already have one case where the problem is we can't deliver data that has not been properly processed. We already see this in the fragment case. We cannot deliver fragments to the application and pretend like they're properly formed UDP payload.
That's correct. And the proposal is that all the fragment data would be sitting in the options area, not in the conventional UDP payload area.
Okay, so we have to be really careful. There's UDP payload area, which is covered by UDP length.
When I say UDP, okay, so we're very, very careful. When I say UDP payload, I mean what is covered by UDP length. The proposal for fragment is that when we're doing fragmentation, all the fragment data, which could cause problems for a conventional receiver if you send it to a conventional receiver, is sitting in the UDP options area beyond UDP length.
Yes, and what I'm saying is there are other cases where, like fragment, where we cannot deliver that data. Encrypted data will have the same property. if we ever do compression. So there's going to be other use cases. We can't deliver, it's gibberish if we deliver it.
I'm in agreement.
Okay.
I'm in agreement, but I don't see the point. So maybe you could try to get on the list again. I agree with everything you said, but I thought it already was agreed. So
Well, Joe's not here, so.
That's good.
Let me just make one more higher level comment.
Yes, sure.
So hang on, let me try to capture where I think we landed out of that, which is that in particular, if there's UDP payload and there's a problem in options processing, e.g. from an unrecognized critical option, you can drop the options, but you can't drop what is described by UDP length.
Correct. Good. Okay, I think there was the term UDP payload versus this might be in an option that's kind of confusing. So we'll have to clarify that. So points 1 and point 2 to me are extensibility. So I think as a design principle, we want to make sure that we can have version 2 of this protocol if necessary, and we can have this option case. So that's why I advocate making extensibility a first order issue here.
Okay, this we should discuss on the list.
Channeling Mike Hurd from Jabber. The problem is that some of the options affect data handling, and in that case, the data and the options must share fate.
Yes.
Tom has said all the things I wanted to say, and we also see it in the encryption case as well.
Again, that's good. Let's try and make sure this level of agreement is actually on the list by following that up on the list and making sure that whether Joe is on the same page. Let's go to the next one.
Okay, and I think the other thing is that I believe that the design direction going forward for how to put a critical indication in the option is the divide up the option space. And it might be the most significant bit if it's 50-50. It might be the two most significant bits if it's 25-75. We'll figure out on the list how to divide it up. But that I believe is the design direction going forward. And I see nobody headed for the mic, so I'll record that as sent to the room.
So we need to decide if light and frag are needed to be supported. I saw the use case mentioned on the list of using frag to support DNS. That might be a very useful use case to try and crystallize. So we're going to follow that one up. But do we need light? That is a real question to the working group. Do we need the light functionality independent of frag? The discussion that the chair saw on the list recently suggested that we might be able to remove the UDP light partial coverage function from the option trailer. So we don't have an option that says this is UDP light equivalent. Does anybody think that we need the UDP light option? Because if we remove that, it would be simpler. And Joe's says there seems to be support for dropping it.
Yeah, the consequence, the discussion about light and where light originally got connected into all of this was if you're trying to do DNS fragmentation because of DNSSEC and you're using UDP options, because OCS has to be present in every single one of those UDP packets, you've got the individual checksum. Do you also need a reassembly checksum? And if you want an end-to-end reassembly checksum, shove it in the application. There's no reason to bar it. And if the application is doing its own reassembly checksum, that does not remove the need for OCS because we still need that to check validity of the options and make sure that the packet goes through the paths that need that OCS compensation to go through.
That would seem to be rather similar to what's done in IPE level fragmentation anyway. Look, Tom.
Tom Herbert. Yeah, if an application cares about integrity, they're doing much more than a checksum. They'll do some strong CRC or something even stronger. So that's not, I don't think that's very compelling to say the application would do a checksum.
So we could provide some weak way of doing this, and we could provide a CRC32 option, but the basic function doesn't need it. is a reasonable thing to confirm on the list.
Yeah, we'll confirm on the list, and in particular, what I just said about a primary focus on does this do something useful for DNS with large DNSSEC payloads also will need to be confirmed on the list as a way to focus the design.
Do we want to create a Part N option?
No, wait a minute.
Oh, sorry, question.
Channeling Mike Hurd. No light option trailer does bad things to legacy receivers.
Okay.
Does bad things to what?
One
Legacy receivers.
legacy. One more voice for not needing light.
Oh, okay. Part N has been proposed on the list as an option. Does anyone want to speak about why it's useful or why it's not useful? Joe's comment is easy to add, so.
Tom Herbert, it is, granted, it's a relatively minor point, but the difference here is, do we want to model stateful options or stateless options? And I think if you're going with stateless options, which you seem closer to, I would prefer the IPv6 method. Implementation-wise, if I have both of these, it's a lot easier because I can use the same implementation for hop-by-hop destination options, now segment routing options, UDP options, same exact code. It would be just convenience.
It's cheap. It's cheap to add if implementers find it. If implementers find it useful, sure.
Channeling Mike. There's already the ACS option for reassembly checksum.
Yeah, right. Yeah, sorry. Answer to a previous question, but yes, I buy that. Okay. Right. Do you have the next slide?
Let's see. Let's see. Rest of the slides.
Yeah, I'll take them.
All right.
Okay. So this is the design goals. Joe's passionate about this, and it does actually help scope the problem. So I think it would be worth people checking on the list whether they think the list of design goals are still valid and whether some of them need to be updated. It would help Joe's thinking about checking the consistency if we check the design goals section of the draft. We're already questioning support for partial checksum coverage, which was one of those design goals. Yeah. So please have a look at these because it would help Joe work through them. Next. This is explaining. There's basic rules in those design goals that say how UDP options work. I think it's good to have a strong model of how you think they'll work. So if you're interested in the UDP options debate, or you've talked on any of these topics on the list, please check those and find out whether the design principles are still correct. Next slide.
Okay. Well,
this one is a summary of the debate we've talked about, so it's in the slide deck. You can look at it. We're short of time, so we probably won't be talking about this now. Is there another slide, or are we done?
This is the last slide. Could you check your tablet and see if there's any other questions we want to quickly ask now before we try to squeeze everybody else into the less than half an hour we've got left?
I have one question that we didn't ask. That was somehow on the list. We talked about a CRC 16 as an integrity check, whereas I thought, David, that we had previously discussed that, remind me otherwise, that it should have been a CRC 32C was used for integrity check as per SCTP and iSCSI. Is that right?
My general sense, I think from this discussion and from elsewhere, is that if we don't use the typical internet 16-bit checksum, we want to use a CRC, the right CRC to use is CRC 32C. Don't waste time on CRC 16 and use CRC 32C because it has incredibly good software support courtesy of iSCSI and SCTP.
I think we covered most of the rest of the stuff. What we really need to see is people check the design principles and Joe to revise the document so that we have a consistent view of all the comments that have been made on the list recently. If you didn't look at it and you're interested, please look at the next revision from Joe because this is beginning to settle down, which is good.
Okay. Now I'm gonna unilaterally bash the agenda. Jerome, you here? Okay. Let's quickly deal with the and now something completely different. Let's quickly deal with the QCI and diffserv draft. So Jerome and Tim, who are the folks who brought us the very useful RFC on how to map between Wi-Fi QoS and DiffServ QoS, went to work on QCI for mobile networks. You saw some comments from some 3GPP folks on the list expressing, let's see, I would say profound reservations. There was a meeting between 3GPP and IETF leadership on Monday, which included this topic. I think Magnus Gorian and I were all there, along with, I think, some other folks in the room. The upshot of that meeting is that there will not be a normative standard in this area, so this cannot be standards track. There appears to be an opportunity to write an informational draft for guidance to non-experts, e.g. those setting up private networks, and there will be more details coming. There is work going on to more precisely record the outcome of that meeting in a couple of paragraphs. When that's all written down and agreed to, we will forward that to the list so that everybody understands where we're going from here.
Interjecting on the previous topic, channeling Mike Hurd, the CRC 16 was agreed on the list some time ago, but I agree this decision should be revisited.
Okay, thanks. Jerome, anything to add?
Jumping back onto this topic. So good morning, Jerome Henry, one of the authors. So thank you, Mr. Chair. I'm looking forward to the feedback from that liaison and the summary of what was said. And I think if, as I hope, the feedback is that they're not opposed to an informative text, one of the first tasks will probably be to clarify the intent of that draft, to express that we're not, intending to impose a map to anyone, but, build a sort of a language translation system so that if people have multipass traffic going through each of these two domains, they have a way to understand what the expression of intent of one mapping in one system means into the other. So once we have that, if we have that feedback and if it's positive, I would like to come back to this group, first of all, clarify the intent and get your feedback so that we can build together a system to see if we can translate those mappings into one to the other, especially as 3GPP has built new definitions of new traffic, which I think are not entirely clearly described in our domain, primarily in the world of IoT. Thank you.
Martin. You probably ought to introduce yourself with the 3GPP affiliation, please.
Okay, so Martin Dolly, AT&T. I represent AT&T in the CT as well as SA3 working groups. Okay, so the table that's being referenced here on QCI in SA2 is an informative table. And the reason why it's an informative table is that just like each of the carriers and their backbones use DiffServ code points differently, the QCI and ARP, which is the priority marking, are also used differently or can be used differently between various different carriers. In addition, particularly as we're moving forward in further defining 5G, that table is ever changing. And so one, it's a moving target, and two, it's informative. So any kind of must language referring to an informative table is probably ill-advised, as well as the fact that it's a moving target. In addition, the guidance, I believe, will be most useful, I think, in 5G for private network deployments. But I don't think it would be necessarily useful at all for carriers who already know how to provision their networks. Thank you.
Let's not.
Yeah. I think we're basically done here. Let's get the text. When the text comes out, we'll see. I think we've got across all the comments. It is potentially useful for private networks. That's at least a good starting point.
Just a word, fully agree. Thank you.
I think what we're expecting here is some informed input and a new revision of the draft, which is clear, and then we can actually restart the process. I think with this one's been on the agenda for 3 items. Never been presented. We've never done it. That's for adoption. That's just for information. We're just discussing what to table.
All right. I'd really like to try to get both these in at 5-10 minutes each. Well, the other option is to push NQB to tomorrow and hope we get to it.
I don't think we'll do that. We'll take Greg.
All right. Sorry.
We're going to because we and hopefully we will try and take Greg's presentation quickly.
Okay.
And because we punted it last IETF and it was a draft up for adoption, and we will try and leave enough time to give you some time.
Which is fine. Yeah.
Yeah.
Okay.
We will do our best.
It is today, right?
Yeah.
I cannot take it tomorrow.
We try our very best.
Okay, thank you.
Greg, can you try to get through the slides in well under 10 minutes?
Okay. All right. Greg White with Cable Labs. For this version of the draft, I was joined by a co-author, Thomas Fasadi, who's, I believe, joining us remotely. Next slide. Right. I presented this draft at the last IETF, and just to reiterate what the goals are of this proposed non-Q building or NQB PHB and code point. The idea is to provide low latency and low loss for sparse traffic flows, and that the code point describes not the wants and needs of the application or some value judgment as to its importance relative to other traffic, but instead is conveying verifiable behavior of the application, that it is sparse and doesn't build queues in the network. And thus there's no incentive to mismark packets that flows that are queue building would get generally better performance if they don't mark themselves as non-queue building and vice versa. So applicability here and actually the driving kind of set of use cases that led to the proposal is in a dual queue L4S link where you've got differentiation between effectively classic TCP in the classic queue versus next generation TCPs with congestion controllers that can achieve ultra low queuing delay in a low latency queue, identifying sparse traffic that can coexist with that L4S traffic in that low latency queue. But in addition, there are likely other link types that can make use of this code point and provide similar support for sparse traffic, in particular pointing out links that have the ability to optimize media access or channel parameters for sparse traffic. The draft in the previous version focused mainly on the DOCSIS link for cable broadband, mentioned Wi-Fi a bit. This version splits out 3 specific use cases, DOCSIS being one, Wi-Fi again being one, and then adds a section on LTE and will include 5G in the next rev. So the main updates between the last draft and this draft, I guess I mentioned the explicit use cases section, but probably the bigger one really is merging in this LOLA concept, which was developed for LTE and was the main aspect that my co-author was involved in. So LOLA, the concept of LOLA was that an application could make a decision between whether it wants a low latency or whether it wants low loss. And that concept, I guess, morphed into essentially utilizing or proposing to utilize the same signaling as we proposed in the NQB draft originally. And with further discussion, we agreed that the definition of NQB as identifying sparse traffic and providing both low latency and low loss was a better outcome in the end. And so that work was merged into the NQB draft. Other changes, additions in the comparison to existing approaches section, mentioned the previous LOLA approach, also referencing an RD mechanism, rate delay trade-off mechanism that was some earlier work as well that we discussed. And then there was a comment at the last IETF that we should discuss the implications on the RFC 8325 mapping of diff-serve to 802.11. And so we've got a recommendation there as well. Okay. The rest of these slides are essentially essentially a review of the slides that I presented last IETF. So I think in the interest of time, I'll skip through those.
Quick note on this one. The most important word in this slide is proposal. Please don't put this DSCP into running code. Please don't do that.
Yet.
All right. The comments that I've seen both on the mailing list and offline. So top one, adding 5G nomenclature in the mobile section. So there's been some discussion on that and what's the appropriate language there. Comment about interesting for mobile networks. The fact that mobile networks have highly varying channel capacity is a aspect that maybe the original use cases didn't have to consider, for example, for cable broadband. And so some interest in running lab tests to understand the queue depth and queue protection implications for mobile networks. And then offline, there was a discussion and relates to the immediately previous discussion around QCI and diff-serve mapping. We have a line in the NQB draft that says for LTE, you must use a low latency barrier with QCI 7, and the suggestion was let's not be normative on that, at least on the QCI piece of it, and say must use a low latency barrier, e.g. with QCI 7.
And Martin Dolly, thank you for your help with this.
And then a number of folks have chimed in on the mailing list expressing their interest in this draft and utilizing the functionality that it defines. And I think with that.
Okay, take questions and then we.
Questions first.
So, Subhir, thanks for this draft. I have actually, and also thanks for, softening that language must, but I actually read the draft and I see that for Wi-Fi sections, you had recommendation should, but for the LTE section, you had must. So is there any specific reason for that? Because I would prefer, I think that even this should be should, not the must, because as Martin said that it's evolving and not specifically even giving the example, because I think Wi-Fi section, I like that section. So if this section can be matched with similar tone, I think that would be better.
Probably the reason for the difference between must and should actually comes from which of the two co-authors wrote that section.
I see. Okay. No, but yeah. So, but I thought that possibly we'll accommodate that.
Yeah, I don't think there would be any concern. I'm speaking more on behalf of my co-author, but yeah.
And should this go ahead, this is obviously something that the working group would have to decide on. Yes.
Likewise, I observed in the draft, you have a should requirement for protection against mismarked flows.
Right.
My observation is that an implementation that doesn't implement that should is in a very sorry state indeed. And if you assume that the implementation can automatically classify flows into non-queue building and queue building flows, well, why did we need a DSCP to start with?
So the first part, actually, the suggestion that be a must to support queue protection was mentioned on the last IETF as well. The reason that I left that as a should is I think that there are some some Q disciplines that would not need to implement Q protection, in particular an FQ system where there's isolation per flow, maybe wouldn't need to.
That was my next thought.
Yeah.
So let's suggest maybe we would need more text to give examples of why it's written the way it is.
Yeah, okay, sure.
Yeah, so with this again, I think one additional points, I read the security consideration. I think it's a good thing, but maybe that's a little bit elaboration will be good. Who is responsible for marking this? You mentioned about that no integrity protections in on-path attacker can change it. Adding somewhat the consequences would be if someone does that. I think that would be a good thing, to add in that section as well.
Okay, fair enough.
So my next question to the working group is who has read this document? So I'd like a show of hands. Oh, that's a reasonable number. I need to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Yeah, maybe 12 to 15. So that's good. Of the people who've read it, or maybe in general? No, in general in the working group then. Can we have a hum for people who think that this topic is a topic that might be worth further study? Without reflection on this particular draft, I'm just asking on the topic. So please hum if you think this is a topic that this working group could usefully do work on. And then I'm going to ask for a second hum for people who think we shouldn't work on it. So first, please hum if you think this is a topic that this working group should explore and do work on. Please hum now. Thank you. Please hum if you think this is a topic that this working group should not do work upon. Please hum now. That was very helpful.
Strong hum, okay.
There was one
For the
comment.
recording, strong hum in favor, no silence against.
And from Jabba?
Hum in favor.
Thank you. That's useful feedback. You've asked for working group adoption. What do the chairs think at this moment? Should we?
Let's go ahead and have a hum since we're adoption.
Okay.
That's good enough.
Okay, please hum if you think this is an item that this working group should adopt. Please hum now. Please hum if you're in doubt that this is an item that this working group should adopt. If you think there is some reason we should not, please hum now. Please come to the mic if you have any comments on what we've just discussed. And our AD will follow the end of the queue that's forming.
Yeah. Magnus Westler. Yeah, I mean, that seems very clear that we can adopt this. The shares, I'll have the shares need to write up and work item.
Yes. The chairs will also ask on the list to confirm that anybody here is in agreement with the sense of the room we see. Yeah. So we see a sense of the room supporting this. Thank you for the presentation. We will confirm on the list and then we'll work with our AD to decide what to do.
Yeah.
Okay. We would like to provide some time for a presentation where it's been squeezed a little bit and it probably has a lot of slides. So please use the time as you see fit to tell us a bit about QoS and Yang models, please.
Absolutely.
And why you're here, first of all.
So if you can put the other presentation first.
The other one. The other presentation first. Okay. But still tell us why you're here and who you are.
Okay, yeah, absolutely. So my name is Asim Chaudhary and we had been working on QoS Yang model. So to give you a little background on this particular work, this particular draft was part of the NetMound working group. And there we realized that it required a little more analysis from the QoS side, also a little more understanding on the Yang side. So this particular draft was moved into routing working group from NetMound working group. 07 version of the draft, we had adoption call on this one. And one of the comments which came out of that was, why not we present this in TSV working group, take additional comment from the community, as well as promote the QoS work in this community. So that was the idea, to present it here and get some additional comment on that. So I'm going to cover this topic very quickly. This doesn't work. Next. Okay. Okay, so next one. So I already explained that one. Maybe we can go to the next slide. Okay, so to come up with a model which is common across vendor is very challenging task. The reason being all the vendors, or there are so many QS construct across industry that to fit one particular construct for all vendors is very, very difficult. So, but we realized that there are a lot of commonalities. There are a lot of commonalities on the QS parameter, as well as the way vendor apply the QS configuration on the devices. And so what we realize that typically all vendors create a QS policy and apply on interfaces in ingress and egress direction. So by understanding that, we came up with this model where we converted the model into three set of layers. One was the base layer, which consists of classifier, action, policy, and target. So the classifier is nothing but a set of filters, and policy is a list of classifier associated with the corresponding actions. So now in the policy, we can have a classifier which could be referred, or it could be inline configuration of the matches. So we created this base model, and then we created a derived model which consists of a diffser module, queuing policy, and scheduler policy. These derived modules took the base element, stitch it together to create this policy. And despite all this, it is possible that a vendor has its own set of requirements for its own set of features, so which can be done by vendor-specific augmentation to the model. So as I already explained, there's a classifier module which is referred by the name, contains a list of filters. There's a policy module which contains set of classifier with the corresponding actions. The classifier could be referred by a reference, or it could be a filter parameter which is there in line. Yes. This is a typical Yang tree diagram where you can see that classifier has a list of filters. Similarly, this is a Yang tree diagram which contains a list of classifier with the corresponding actions. You can see that the classifier can be defined in line or reference. Now, this is action module which contain metering, marking, queuing, and scheduling actions. The one red, two color, one red, three color, and two red, three color is taken from previously defined RFC 2697, 2698. Some of the queuing and scheduling parameter have been taken from RFC 3289. Next slide. I think I already explained all this, except that the diffser module contains diffser related parameters, which is 5 tuple as well as the DSCP value. In addition to that, we can define queuing and scheduling parameter in line to the policy.
One very small nit, you can't use ranges with DSCPs, use a list.
DSCPs are not a set of uniform things, so you can't use a range, you must use a list of DSCPs.
Okay, I see.
If you want to use a range, expand the range, list DSCPs, just do it.
Okay, okay, I see. No, that is how typically it is finally configured into the devices. Okay, so queuing policy will contain queuing related parameters, and we can always refer to 3289 for those parameters. Scheduling policy will contain a queuing policy as well as min rate, max rate at that level. Next. Yeah, means all the vendors have their own set of features which can be easily augmented to the model, and they can enhance the model the way they want. So in summary, we have defined a base set of modules, and then we have, based on those base set of modules, we have created derived set of modules. It is pretty much adaptable to any vendor requirements. It could be augmentable to any specific vendor-specific parameters, and it is pretty extensible. Next slide.
Okay.
Yeah, please go through the draft when you get time, and please provide some comments. Thank you.
Can I ask people to come to the mic if they have comments, and also to think, because I'm just about to ask whether anyone in this room can help in this initiative, because this room has expertise in running networks with QoS, and it has expertise in DiffServ. Is there anybody here who is willing to help? Well, please use the list to ask as well, because I think that with a little bit of encouragement, we should be able to find some people to help read this.
Yeah, so if we have a couple of minutes, I can cover the other slide also.
Next slide. Next slide deck, please.
Thank you.
Is this up for adoption in routing area?
Absolutely. Means this is a candidate for adoption. And we already went through one adoption call. We got comments, we incorporated those. So it is pretty much on that line.
Okay, that's good. Next slide.
My impression was, I think it's being adopted by RTGWG.
Okay, yeah. So one thing I would like to explain here as part of this presentation is that we created a separate operational model. The reason being config model was too detailed, and operational model required its own set of analysis on the counters part. And so we went through all the different discussions. So we thought that it's better idea to have a separate model for operational, and where we can detail about the statistics for QS. One other thing is that, nowadays there's a lot of talk about network visibility. So the way we present the counters to the providers is very, very important. And so for network visibility, how we present has to be thoroughly discussed, which has been done in this particular draft. So essentially, these are the basic elements for any QS policy which can be applied to interface. We have per classifier statistics. We have policy statistics, we have metering and queuing statistics. In addition to that, we have name statistics, which is very similar to classifier statistics, except that it has a common name across the classifier. When it does happen, that means we aggregate those counters. This is very, very beneficial for low-end devices where the resources for hardware is very, very scarce. So other than that, yeah, it's usual stuff. We have metering statistics for all the different kind of policy. And we have stats for confirm bytes, confirm rate, violate, exceed actions. Similarly, we have queuing stats, which is regarding the queue, what is the length of the queue, how many packets were dropped through it, how many packets are there in the queue, and pretty much that. So if you get time, please go through the draft and please provide the comments.
Thank you ever so much for making that so short. If you have questions, please speak to the gentleman here.
Absolutely.
Please use the list to discuss. I think we need to conclude that this meeting's over for today. Please come back tomorrow where we'll have the other items on our schedule.
Thank you.
Have a good lunch.
For anyone that hasn't signed, the blue sheets are up here.
No problem. I mean, I suspect that we try.